Hello and welcome back. We'll continue our question discussion from electric charges and fields. We'll now focus on the second part of the chapter, which deals with electric flux and Gauss theorem. The first question here says, in a region of space, the electric field is given by E vector is equal to 8I cap plus 4J cap plus 3K cap. The electric flux through a surface area of 100 units in the XY plane is. Now, the electric field here in this case is uniform. You can see that from the field vector given. And we need to find the electric flux passing through a surface area that is kept on the XY plane. And the area has a magnitude of 100 units. Now, since the field is uniform, since electric field is uniform in this case, I can say that electric flux phi E passing through the surface will be equal to E vector dot S vector. E vector is the electric field intensity vector in that region, and S vector is the area vector of the given surface area. Now, E vector is given to us directly, but we need to find the S vector. How do we do that? This area here is on the XY plane. So please consider this is your x-axis, this is your y-axis, and this here is your z-axis. Now, the surface is somewhere here on the XY plane. We need to find S vector, and S vector will definitely have two components. One is its magnitude, which is given in the question, and its direction. Its magnitude is very clearly given as 100 units in the question, and the direction is to be found out. If this is the area S, the area vector S vector will be in the direction that is perpendicular to the surface. And since the surface is on the XY plane, we can see very clearly that S vector will be in the direction of K cap. Now, the direction can be now represented as K cap. So finally, we have our S vector. So we can say that phi E would then be equal to, instead of E vector, we'll write down 8I cap plus 4J cap plus 3K cap. And that dot, the area vector S vector is 100 K cap. If you do the dot product of these two vectors here in rectangular component form, your answer will be a scalar, and that will be 3 into 100, that is 300 units. It's a very simple, straightforward question. It is based on the equation to find out electric flux through a surface kept in a uniform electric field. If this electric field was non-uniform, then you would have to use integral calculus here to find out the electric flux. But this is very simple. 300 units, option B is the correct answer.